Welcome. Today we're going to talk about how to solve absolute value expressions and equations. So by the end of this, I hope you will know how to evaluate a given expression if I give you some values. And similarly, I hope that you are able to solve an equation and identify the sometimes two, sometimes one possible solution for an equation. All right, so we put the blurb about absolute value here again, the formal definition, just to refresh your memory, although we did talk about it last class. What I really want you to remember is that absolute value of anything is just the distance from zero that number lives, right? So in our example, the absolute value of -4 is going to be 4 because it lives 4 units away from zero. Similarly, if I were to look at the absolute value of 5, that would be 5 because it's 5 units away from zero. So it's important to continue to keep in mind what the absolute value symbols actually mean with respect to distance from zero. So when we're solving equations, there are some steps that we can take. The first step is just to remember some basic rules. Always simplify inside the absolute value bars first, remembering that absolute value bars are grouping symbols, much like parentheses and brackets. So we want to make sure that we simplify inside the bars first. The second thing to remember is that we never distribute inside the bars. So if you have 6 times the absolute value of 2x, you would not distribute that 6. All right, so that is the first thing to remember. The next step in solving an equation, an absolute value equation, is to isolate the absolute value bars. So you want to get the absolute value bars completely on their own. That is our first step. Once you have the absolute value bars isolated, then we need to set up 2 cases, a positive case and a negative case. Because remember, we are trying to find how far a number is from zero. And we can go in a negative direction, we can go in a positive direction, but both of them will come up with a distance from our zero. And the last thing we want to know, similar to all of our solving equations, we want to check for extraneous solutions, and we do that by substituting our solutions into our original equation. All right, so I'm going to skip around here. Since we just talked about that, I'm going to have us look at some absolute value equations. We're going to solve each one of these, and we're going to check for extraneous solutions. So if we remember, the first step was to isolate the absolute value bars. And in this case, you'll notice the absolute value bars are already by themselves. So we don't have any of that isolating to do. The second thing we're going to do is we're going to set up 2 cases. Case 1 is the positive case. And when we set up our 2 cases, we are going to drop the absolute value bars. The first case is the positive case. It could be the negative as well. I'm just going to do the positive one first. So this would be case 1, right? And then our second case, I'll put this over here, case 2, is the same absolute value, but this time we are going to set it equal to a -45, because whatever this is, whatever's inside the absolute value has to be 45 units away from zero, and both 45 and -45 meet that criteria. From here, we solve each equation independently. I add 5 to both sides, I get x equals 50. I add 5 to both sides, and I end up with x equals -40, a simple one-step equation. So those are my 2 solutions. Now I check to see if there are extraneous solutions. So I'm going to put a little check here. To check, I'm going to substitute 50 back into my original equation. So if I do, and I'm going to make it green because it was our positive solution. If I substitute 50 minus 5 into my equation and I evaluate this, I do 50 minus 5, which is 45. And I'm asking myself, I'm going to put a question mark here. I'm asking myself, is the absolute value of 45 equal to 45? And yes, the absolute value of 45 is 45. So that is not an extraneous solution. That solution is verified. I'm going to check the next case, And in this particular case, we looked at -40. And then I'm going to subtract 5 from that. And I'm asking myself, is that equal to a -45? Is that equal to a +45? Sorry, it's +45. These evaluate to -45. The absolute value of -45, is that equal to 45? And again, because we're talking about the distance from 0, how far is -45 from 0? And because that is actually 45 units, I have verified that solution as well. All right, let's look at another one. Remembering that step 1, I'm going to zoom in just a touch if I can remember how to do that. Whoa, check it out, it got so big. Okay, remember step 1 is to isolate my absolute value symbols. I notice that there is a 16 on the same side of my equation as my absolute value bars. So I need to move that to the other side. And I do that using inverse operations. And I'm going to subtract 16 from both sides. I end up with a new equation that is equivalent, that reads the absolute value of 5b plus 9 must be equal to -14. And I'm going to stop us here because we need to think about what do the absolute value symbols mean. In this particular place, no matter what's inside here, I'm asking, when will it be -14 units away from 0? And at that point, some alarm bells should go off in your head because remember, we can't ever be negative units from 0. So this would be a giant no. This is a no solution equation. It is no solution because we will never be a negative number of units away from 0 on a number line. All right, those were two pretty simple equations, but you're good at solving equations, so I feel confident that you can isolate your absolute value, and from there, you create your two cases and solve accordingly. Let's look at another skill which is useful to have. In this particular set of examples, what we're going to do is we're going to evaluate a given expression. In this case, I'm a little bit too far out, so I'm going to zoom back out. Love it if there was a happy medium in here. I'm going to evaluate each expression, recognizing that the value of w is given as -4, x is given as 2, y is 1/2, and z should be evaluated as being a -6. We are going to substitute these values in for the variables in example A, and then we're just going to simplify this. So the 5 is just a 5. I'm going to do my substitution first. I like to use color. W is -4, so I'm going to put a -4 there. I'm going to add to that Z. Let's make Z green. Why not? And green is a -6. So this is what I am going to evaluate. I evaluate inside my absolute value bars first. 5 does not change in this case. -6 plus -4, sorry, -4 plus -6 is -10. I have now simplified inside my absolute value bars, and I can evaluate this. The distance of -10 from 0 is going to be 10 units. I now finally can add these, and this expression, 5 plus the absolute value of w plus z, should evaluate to 15, and that is it for that one. Let's try another. In this particular one, I'm asked to substitute the value of x, which is 2. It lives inside my absolute value bar. I'm going to add 5 to it, and then I'm going to subtract 2 times the value of w, and we know that w is -4. I'm going to put the -4 in parentheses to protect it. And now that I've done my substitution, I need to simplify inside my absolute value bars first. I have 2 sets of absolute value bars to simplify. 2 plus 5 is 7. Minus 2 times a -4 is -8. Now I'm going to evaluate each of these. The absolute value of 7, or the distance from 7 to 0 is 7. And I'm going to subtract from that the absolute value of -8. If I think, how far is -8 from 0? It is 8 units. And then now that I've eliminated my absolute value bars, I can just do a simple subtraction problem here, and I evaluate this expression to -1. Last one. In this particular case, I'm looking at the absolute value of W, which we said was -4. I'm going to subtract from that 4 times the value of X, which in this particular case, again, was 2. I'm protecting him inside of parentheses. I simplify inside my absolute value using order of operations. In this particular case, I do -4 times 2 first. And that gives me a -8. And now I simplify negative -8, which evaluates to a -12. The distance of -12 from 0 is 12 units. And I have simplified my last expression. That's it, folks. I can make these slightly more complicated, but the steps are always going to be the same. Hope you enjoyed today's lesson, and I'll see you soon.